All right, welcome to finally the last section of our trig chapter. This is section 9.8, using sum and difference formulas. Okay, and the essential question that at the end of this section that you're going to want to know is how can you evaluate trig functions of the sum and difference of two angles? Okay, that's our important question that we're gonna hopefully be able to answer when we're done. What you'll learn, so these are in your notes, so you'll know if you're studying what to look for. Guys, this is use this line to get a date here, so hopefully after doing our trig identity section last time, that will make sense to you. To begin this section, we need to think back to what we did on those special triangles on your note card. So we have the 45, the 30, the 60. And what we want to do is we want to jot down our sine, cosine, tangent of these three triangles so we have this information handy for the problem. So sine of 45, remember, is opposite over hypotenuse. So root 2 over 2. So this one is root 2 over 2. Cosine is adjacent over hypotenuse, so also root 2 over 2. And lastly, we have tangent, which is opposite over adjacent. So we have root 2 over root 2, which is just equal to 1. Okay, so sine root 2 over 2, cosine root 2 over 2, and tangent is equal to 1. Okay, so let's do the same thing for 30. Sine is opposite over hypotenuse, so 1/2. Cosine is adjacent over hypotenuse, which is root 3 over 2. And tangent is opposite over adjacent, so I'm just going to do that for us, so root 3 over 3. And last but not least, we have sine of 60. So root 3 over 2 is opposite over hypotenuse. Cosine is adjacent over hypotenuse, so 1/2. And tangent is root 3 opposite over adjacent, so root 3 over 1, which is just root 3. Okay, so we're going to need to recall back to these at a later time. All right, so what are these sum and difference formulas? So in here, I've given you the chart. This chart has the sum formulas are sine of a plus b, cosine of a plus b, and tangent of a plus b, and then what it's equal to on the right. And I will not make you memorize these. I will always give you these on a test or a quiz. And on the left, or on the right, sorry, we have our difference formulas, which is a minus b, and a minus b, and then what it's equal to on the right. So we're going to refer back to this chart, but just know that I will always give you these. I'm not going to make you memorize these formulas. All right, so what would an example look like of these using these formulas? All right, so we have sine of 15 degrees. And prior to this, we used to just type this in our calculator. Since this is not a 45, a 60, or a 30, we can't really find the exact value of these. But what we can do is we can use our 30, 45, and 60 to get 15. Okay, so hopefully you would agree that 60 minus 45, 60 degrees minus 45 degrees would be 15, and we can use 60 and 45. Or, how else could you do this? You could probably do sine of 45 degrees minus 30 degrees, which is also 45 minus 30, which is also 15. You will get the same answer no matter which one of these you use. So we're going to just pick one. We'll just do this first one here. Okay, so let's see what we get here. So we are going to do 60 minus 45. And what we need to do here is we need to refer back to our sum and distance formulas in order to come up with which one we're going to use. So it's 60 minus 45, and we're doing sine, so we're going to use this formula here. Okay, so the A is 60 and the B is our 45. Okay, so what I'm going to do is I'm going to take sine of A, cosine of B, and minus cosine of A, sine of B. Okay, so I'm going to write, skip one too far, I'm going to rewrite this. So sine of 60 minus 45 is equal to sine of A times cosine of B minus cosine of A times sine of B. And I got that right from our formula sheet. So now all we have to do is we're going to fill in this information with what we know. Okay, so 60 is my A and 45 is my B. All right, so what's sine of A? Okay, if A is 60 degrees, what's my sine of 60 degrees? So we need to go back to those numbers that we have. So sine of 60 is root 3 over 2. Okay, so this one is root 3 over 2. and we're going to multiply that by cosine of b. Well, b is 45, so cosine of 45. So what's my cosine of 45? Root 2 over 2. Okay, so this one is root 2 over 2 minus cosine of a. Remember, a is 60, so what's cosine of 60 degrees? Cosine of 60 is over here, so it's 1/2. So I'm going to put 1/2 over here, so 1/2. And I'm going to multiply that by sine of b. And remember, b is 45, so sine of 45. Sine of 45 is root 2 over 2. So, and now all I'm going to do is I'm going to multiply these together. So I have root 3 times root 2. Root 3 times root 2 is root 6. 2 times 2 is 4. Minus 1 times root 2 is just root 2. And then 2 times 2 is 4. All right, so notice we have two fractions with the same denominator, so we don't need to combine our denominators or get like terms. So the bottom is going to be 4, and then I have root 6 minus root 2. Okay, and then that is going to be our answer. Now, how can we check this? How do I know that this is right? So let me open up the calculator really quick. I probably should have already had that done. That's okay. And all I'm going to do is I'm going to just do this math here. I'm going to do square root of 6 minus square root of 2 and enter, and then I'm going to divide that by 4, and I get 2.59. 2.59. So this is equal to 2.59. And then I can now, how can I check and make sure it's right? Well, I can just do sine of 15 because that's what we're trying to figure out. Sine of 15 degrees is 2.258, 2.259. Oops, I wrote. It's actually 0.259, not. And then if you do just sine of 15 degrees, you get the same thing. So we know we did it correctly. So all of that is equal to root 6 minus root 2 over 4. All right. All right. So it's the second example. Same thing, but however, now they're going to give it to you in radians. So what I need to do is I need to figure out what this is in degrees. So I'm going to multiply by 180 over pi, cancel my pi's. 2 goes into 180 90 times. All right. So, oops, I wrote this wrong. I do apologize. So please fix this in your notes. This should say 7 pi over 12. Okay, so it should say 7 pi over 12. So I'm going to do 7 pi over 12 times 180 over pi, and then I'm going to simplify that. So pi's cancel. Half of 12 is 6, half of 180 is 90. Half of 6 is 3, half of 90 is 45. 3 goes into 45 15 times. And then all I have left here is 7 times 15, which is equal to 105. So really, I'm doing tangent of 105 degrees. All right, so my question now is, I'm going to get rid of this since we don't need this anymore. How do I get 105 using 60, 40, 5, and 30? Okay, so I can do tangent of 60 plus 45 degrees. And that will give me my formula that I'm going to use. So it's 60 plus 45. So I'm going to go back to my chart. So what you're going to use, and I'm going to leave this one for you to have complete for tomorrow, and then we'll go over it in class, is we're going to use this formula, okay? And then what we're going to do is we're going to come up with our exact answer for tangent of a plus b. So I'm going to stop there from this one, and I'm going to leave the rest up to you, and then we'll finish that tomorrow, okay? All right, so now we're going to go to example 3. There are 3 different types of problems in this section. So that was problem type number 1 that we just completed. All right, next one. It says right here that we are solving cosine of a minus b. So I'm going to rewrite this down here. Cosine of a minus b. And what I'm going to do is I'm going to write what that's equal to. So I'm going to go back to my chart, a minus b. All right, so where are we at here? So here's my cosine of a minus b. This is the one we're going to use for this one. And I'm going to rewrite this. So it says cosine of a times cosine of b. So cosine of a times cosine of b, and then what does it say? Plus sine of a sine of b, plus sine of a plus sine of a sine of b. Okay, so we're going to fill in all this information. Okay. So basically, though, what does it tell us? It tells us two of these pieces of information. It tells us that the cosine of A is negative 4/5. So cosine of A is negative 4/5. We don't know cosine of B. We're going to have to figure that out. And what else does it tell us? It tells us that sine of B, so this one, is equal to 5/13. So we need to figure out is sine of A and cosine of B. Well, if you notice here, what do they show us? They show us, they give us some information here. It says that this cosine right here is located in that quadrant. Okay, so let's recall. So we have 0, pi over 2, pi, 3 pi over 2, and then we finish at 2 pi. So this angle right here is located between 3 pi over 2 and pi. So here's pi, here's 3 pi over 2. So my triangle is going to be in the third quadrant. Okay? And then now let's figure out where, and this is going to be our A triangle because it's cosine of A. Now this one, the sine of B, is located between 0 and pi over 2. So where is 0 and pi over 2? Well, here's 0, here's pi over 2, so it's going to be in the first quadrant. And that's going to be our B triangle. Okay? So let's label what we know here. Let's label everything that we know. So in our A triangle, we know that the cosine is adjacent, and then we know the 5 is the hypotenuse. So 5 is my hypotenuse, remember here's my right, and adjacent is 4. So my adjacent is 4, but it's going to the left, so it's going to be negative 4. And remember, theta is always next to the origin. Okay? And then the B triangle, okay, we know is opposite. So here's my theta, so opposite is going to be 5. And it's going up, so it's positive 5. Let me get rid of this 0 here. We don't really need this right now. We don't need this right now. All right, and what else do we have here? And we know that sine is opposite of hypotenuse, so my hypotenuse here is going to be 13, since this is my right angle here. So what we need to do is we need to figure out what this missing side is and what this missing side is, and we can use a squared plus b squared equals c squared. And I'm going to save a little bit of time here, I'm going to do that figuring out for us. Okay, so on the A triangle, when you do the Pythagorean theorem, you actually get 3, but it's going down, so it's going to be negative 3. And on the B triangle going right, we're actually going to get 12. Well, it is positive 12 because it's going to the right. So now on the A and the B, we have all 3 of our sides. Okay, so what do we need to figure out over here? Okay, so what we need to figure out over here is cosine of our B triangle. Cosine, remember, is adjacent over hypotenuse. So here's my theta. Adjacent is 12. Hypotenuse is 13. This one is 12 over 13. Okay. Plus, and we know sine of B, so now we need to figure out sine of our triangle A. So here's A. Sine is negative 3 over hypotenuse. Remember, it's opposite over hypotenuse. So opposite is negative 3. Hypotenuse is 5. Negative 3/5. Okay, so we have all our information. Now we just need to multiply. So let's see what we get here. So we have 5 times 13, which is 65. We have negative 4 times 12, which is negative 48. And we're going to add this to 5 times 13, which is 65. So we have nice common denominators. And then we have negative 3 times 5, which is negative 15. Okay. So let's see what we have here. So we have common denominators, so we can just add these. So my final answer is going to be 65 on the bottom, and negative 48 plus a negative 15 is negative 63. So cosine of A minus B is equal to negative 63/65. Wow, that's quite a problem. Okay, so this problem we're going to do in class, so you do not need to do this. You can if you want to get a little bit of extra practice. And you can see if you got it right, but we will do this one in class tomorrow to make sure everyone's on the same page. All right, so that's problem type number 2. And last but not least, we have problem type number 3, which is probably the easiest. Okay, so let's see what we have here. So once again, we're going to see which sum formula we're using. We're going to do cosine of A plus B. Cosine of A plus B, but this is really x plus pi. So we're going to do the cosine plus. So here is our formula that we're going to use. It's the cosine of A plus B. So cosine A cosine B minus sine A sine B. So cosine A cosine B minus sine A sine B. Okay, so remember, so how do we do this? Here's our A, here's our B. And what we're doing here is we're simplifying, so we're going to see what that means in a second. All right, so what is my A? My A is x, so cosine of x times cosine of B. What's my B? Cosine of pi minus sine of A, so that's sine of x, times sine of B, which is sine of, what's our B? Pi. Now, if you think about this, we know what the cosine of pi is and the sine of pi. So if we draw our xy plane, remember that we have ordered pairs here. Once again, 0, pi over 2, pi, 3 pi over 2, and 2 pi. We have cosine of pi and sine of pi. Well, what's the ordered pair here at pi? The ordered pair at pi is -1, 0. Okay? So remember, x, y, cosine equals x, sine equals y. All right, so on this one, we don't know what cosine of x is, so I'm going to just bring that down. We're going to multiply that by cosine of pi. If cosine's x, what's my x value? -1. So this cosine of pi is equal to -1. And then we have minus sine of x. We don't know what the sine of x is. And now we need to figure out what the sine of pi is. Sine deals with y. What's my y value? 0. Okay. All right, so let's do our multiplying. What's -1 times cosine of x? Well, that's negative cosine of x. And then we have minus, what's sine of x times 0? Well, that's just 0. 0 times anything is 0. So what's negative cosine x take away 0? Well, that's just negative cosine of x. And there is our simplified answer. Okay. Now, these are confusing. I do apologize, but I think you can handle these. I'm going to leave this one. We're going to do this one in class. Do in class. Or you can do it now and check your answer when we do it in class and see if you can get it right. But it's the same thing as the last one, except it's sine and it's x minus 2 pi this time. Okay. So that wraps up the trig chapter. These last two sections are fairly, are pretty challenging for you, so I hope. But I will see you tomorrow, and we'll make sure we go over these.